So homogeneous and non-homogeneous linear equations. Basically, a non-homogeneous linear equation, an equation of the form ax plus by is equal to k, a very simple equation. It is non-homogeneous if a is not equal to 0, b is not equal to 0, and k is not equal to 0. And for a homogeneous linear equation, you have the same equation ax plus by is equal to k, and a is not equal to 0, b is not equal to 0, but k is equal to 0. So that is the difference between a non-homogeneous and a homogeneous linear equation. Now, a system of homogeneous and non-homogeneous linear equations. So a system of non-homogeneous linear equations, you have a1x plus b1y is equal to k1, a2x plus b2y is equal to k2. These are two linear equations, and they are a system of non-homogeneous linear equations if k1 and k2 are not 0. Now, a system of homogeneous linear equations, you have the same two linear equations, and they are a system of homogeneous linear equations if k1 and k2 are 0. So basically the values of k determine whether a system is homogeneous or non-homogeneous. Now, consistent and inconsistent system of linear equations. For a system of linear equations to be consistent, it must have either a unique solution or infinitely many solutions. So let me explain what a unique solution is first. So if you have, say, x plus y is equal to 2 and x minus y is equal to 1. If you solve this, you get 2x is equal to 3, x is equal to 3 by 2. And when you plug that into any one of these equations, you'll have the same value. You'll get a unique value for x. So let's put it in equation number 2 here. You'll get a unique value for y. So let's put it in equation number 2 here. You get 3 over 2 minus y is equal to 1. Y is equal to 3 over 2 minus 1. So y is equal to uh, 3 minus 2 over 2, which is equal to 1 by 2. So you get two unique values. You get 1 over 2 for y and 3 over 2 for x. So these are unique solutions. Now let me explain what infinitely many solutions is. So for infinitely many solutions, basically, let's just say you have this equation here and this equation here. When you simplify this equation, it becomes equal to this equation. As you take 2 common and 2 common here, and then you divide it by 2 over here, and you get x plus y is equal to 1 here as well. So both of these equations are equal. And so basically you will not have a unique solution for x and y. You cannot solve them. So they'll have, since they are both equal and lie on the same, they're both lie on the same line on a plane, they'll have infinitely many solutions as they intersect on infinitely many points. So for consistent system of linear equations, basically you either have a unique solution or you have infinitely many solutions. So that's that. Now let's discuss inconsistent system of linear equations. For an inconsistent system of linear equations, you need no, your system should have no solution. What that basically means is, let's just say you have this here, and let's just say you have this here. Now, quite clearly, these both equations contradict each other, as x plus y here is equal to 2, but x plus y here is equal to 1. So, you can clearly see that this will never have a solution, as they are contradicting each other. So, for an inconsistent system of linear equations, this is an inconsistent system of linear equations. Trivial and non-trivial solution of homogeneous linear equations. So remember, homogeneous linear equations are those in which the value of k is 0. So we have these system of linear equations, and first of all, the values of x1, x2, and x3, if you put the values as 0 in each one of these, they will give 0, and this will be uh, a solution. And the solution 0, 0, 0 is the trivial solution. And another solution of the equations, other than the trivial solution, is called the non-trivial solution. As obviously, it is not necessary that the only 0, 0, 0, x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0 will give you 0 as the answer. No, you can have other solution as well, and that will be the non-trivial solution.